Okay, think about this for a second. What if you could build one single invention that could link every person, every machine, and every single idea on Earth? One system to hold all of human knowledge. I mean, it sounds like something straight out of science fiction, right? But it's not. It's the reality we live in every day. It's the internet. And its story is way more complex and a lot more physical than you might imagine.
Picture this. It's the 2012 London Olympics opening ceremony. The whole world is watching. And the inventor of the World Wide Web, Tim Berners-Lee, he types out this simple, powerful message. This is for everyone. Just 4 words. But that sentence perfectly captured the idealistic dream that created the web in the first place. This incredible tool for universal connection, open to absolutely everyone.
So where did this dream of a totally connected world even come from? Well, it wasn't some big corporation's product designed to make a profit. Nope, its roots are actually in academia and military research. It all started as a practical solution to a really complex problem, and it just blossomed into something so much bigger than anyone could have predicted.
This timeline kind of shows how it all evolved. It kicked off way back in the 60s with ARPANET. That was a military project, and the whole idea was to design a network that could survive an attack. So if one part got knocked out, the computers could still talk to each other. By '83, it had its own universal language, TCP/IP, which let all these different networks communicate. But the real magic moment for most of us, that came in 1989 when Tim Berners-Lee proposed linking hypertext to the internet. And by 1991, the very first website was live. The invitation was officially sent out to the world to come and join the party.
And this right here, this is the most crucial point. Berners-Lee and CERN made the underlying code for the web available to everyone. No patent, no fees, nothing. It was a gift. And that single decision is the reason the web just exploded in popularity. It was designed from its very foundation to be a shared public good, a tool for humanity, not a product for sale.
But that beautiful abstract idea of a web of information, it has to live somewhere, right? And this is where the story takes a really dramatic turn, away from the digital dream and toward its very, very physical reality.
It's such a simple question, isn't it? But the answer changes everything. When you hear somebody say the cloud, what do you picture? Something kind of weightless and floating up in the sky, right? Well, the truth, it's a whole lot heavier.
This is where the internet lives. Not in the sky. It lives in millions of humming servers, stacked in these colossal, windowless buildings called data centers. These places are the physical heart of our digital world, and they are constantly consuming enormous amounts of energy and water 24/7.
And the scale of this physical network is just staggering. Back in 2005, there was about 1 billion internet users, but by 2023, that number had surged to 5.4 billion. That's more than half of humanity, and every single one of us is connected to this huge, tangible infrastructure.
So, what's the true cost of keeping this global machine running? It's a cost that goes way beyond your monthly internet bill. Let's take a look at the full environmental price tag.
Let's start with the device that's in your hand or on your desk right now. Get this. To manufacture a single computer that weighs just 2 kilograms, it takes the extraction of 800 kilograms of raw materials. That's a 400-to-1 ratio of mined earth to finished product. Just wild. And here you can see what some of those materials are. Every single smartphone, laptop, and server is like a complex cocktail of minerals and metals that have to be mined. We're talking copper, cobalt, lithium, gold. Our clean, sleek digital world is built on the very physical and often pretty dirty act of pulling resources out of the ground.
And then there's the energy to run it all. By 2026, just the data centers alone are projected to consume 1,000 terawatt-hours of electricity. Now, that number is so huge it's almost meaningless, so let me put it in perspective for you. That is more than the entire country of France used in all of 2022.
You know what's really surprising, though? It's where the impact happens. We tend to think about the electricity our phone uses when it's plugged in, but that's only about 20% of its total carbon footprint. A massive 80% of its environmental damage happens during production, before you even turn it on for the very first time.
And this environmental burden, it's not shared equally. Not at all. There's a concept for this, it's called ecologically unequal exchange. It basically means that the benefits of our digital lives are concentrated in some parts of the world, while the costs are just offloaded onto others.
I mean, this contrast says it all, doesn't it? On one side, you have the marketing, that clean, abstract promise of data flowing through a beautiful green landscape, and on the other side, the physical reality, literal mountains of electronic waste, often processed in developing countries with absolutely devastating costs for the environment and for human health. Just look at this disparity. In developed countries, each person generates over 3 kilograms of e-waste from small devices every year. In the least developed countries, it's just 0.21 kilograms. That's a 15-fold difference in consumption and disposal. It's huge.
And here's the thing. While developed countries produce the most waste, they also have better systems to deal with it, collecting nearly half of it. But in developing countries, where so much of this e-waste ends up, the formal collection rate is a shocking 7.5%. The vast majority is just left to pollute the local environment.
Okay, this is a pretty bleak picture, I know, but it's not the end of the story. The challenges are massive, but so are the opportunities to completely rethink our digital world and build something more sustainable. So, the real question is, what's the path forward?
The key concept here is a circular digital economy. Instead of the straight line we have now, take, make, waste, we move to a loop. It's all about minimizing what we take from the earth and maximizing the life and value of everything we've already made. Repair, reuse, refurbish, recycle.
And here are the steps to actually get there. First, it starts with design. We have to create products that are built to last and can actually be repaired. Second, it means we have to demand responsible mining and production. Third, we need a global investment in real waste management infrastructure. And finally, and this is crucial, it's going to take international cooperation to make sure developing nations share in the benefits, not just the burdens.
This image is just such a powerful reminder of the legacy we're creating. Every single device we throw away has a physical presence that's going to long outlast its software updates. Here, you can literally see nature reclaiming our digital past, showing us that nothing we create ever really disappears.
So we're left with this one big question. We built this incredible tool for humanity, one that truly is for everyone. But along the way, we've discovered its deep, unavoidable connection to the physical world. The challenge for our generation now is to honor that original, idealistic vision by building a digital world that doesn't just connect us, but one that also sustains us and our planet. How do we build one that lasts?